All right, so we're gonna do some more chapter 3 today. We're not gonna finish chapter 3 today. We'll do a little bit more tomorrow, but chapter 5 stuff is really short. I do want to point out to you, maybe we can start with that real quick. Let's come over to the PC and look at the syllabus. I will click on your guys' syllabus, even though it's the same, just so you can see it. The midterm is next Thursday. It covers everything on the Tuesday before. You are expected to have done the chapter 1, 2, 3, 5, 6, and 7. Chapter 4, I have here for stuff you should be working on, but it's not due till the weekend, and it's not on the midterm at all. This day's content is not on the midterm. You can see right here, it doesn't say 4, and it says 5 to 7.2. Those are the topics that are on the midterm. So there is a gap in there that like you'll have an extra day to like get stuff done. I have the homework for chapter 5. Let's see, what day is that? The midterm is going to be available. It's Thursday through Sunday. So I'm giving students, it's not like you can be working on the homework all the way up to the Friday or Saturday. There is going to be a practice exam available. Right now it's set to not show up right away. I think I'm going to make it show up Friday for students that are like going home and doing each chapter's homework every day, like staying on the ball so they can have more practice. I encourage you to go through the practice exam a few times. There are more questions on the practice exam than there are on the actual midterm. So when you see it, just know that the midterm's shorter. But the questions, a lot of them are very similar. So if you go through the midterm a few times, they'll give you different types of questions. But if you know like what type of content's being tested on, you'll be ready to kick ass on the midterm when you take it, okay? All right, now we can get back to 321. And this is more chapter 3 review. So, yesterday we were doing algebraic expressions or algebra expressions. Today we're going to do algebra equations. In one variable. Chapter 4, which isn't on the midterm, and there's 2 variables. That's where you get your whole graphs that you see. You see a lot of. There's a lot of uses for them in real life, business and economics. Most graphs you see are based off of this 2 equation or 2 variable thing. Today we're just doing 1 variable. They call them linear equations. I really don't like it because two variables is also linear equations. It's got the word line in it. And the solutions appear on a number line. If I have x equals 3, that's a point on a number line. When solving equations, or finding the solution, that's what we call the answer, is the solution. The idea is isolate the variable. Get it alone. You're a predator animal, and you've got a pack of bison, and you want the slowest, weakest one. Try to get alone so you can take it down. So if you don't get it alone to take it down, though, the bison stomp on your head. But you can scare them, get the slow one staying behind, and you can take it down and eat. Similar idea, a lot less bloody. All right, so when we say equations reminds us of the word equal. have the same characters as equal for the most part, and it means there's an equal sign in them. So we could do something like 2x plus 5 equals 3, and we have a linear equation. Now, I don't know if I'm going to do this justice here. When you see a set of scales, they generally you want the scales equal. That's a scale, even though it doesn't look like it. That's one of those old scales and shit. They put weights on both sides, and the idea is to keep the scales equal. Same principle applies here. If you've ever used one of those scales in like a science class or chemistry or something like that, if you add something to one side, you got to add the same amount to the other side to keep it balanced. That principle applies here. Keep the equation balanced. And what that means is what you do to one side, you do to both. And I'm going to give you a list of little things you should do in the order we're going to do them, and then we'll solve this equation on the next page. 1, get rid of fractions or decimals first. And we'll show you how to do both, but we're not starting there. Start with an easier problem. After that point, you'll have something like this where you only have whole numbers or integers. Then deal with the addition and subtraction by doing the opposite to both sides. And then 3, deal with the coefficient by, again, doing the opposite. At this point, it should be, it is multiplied, so to do the opposite, we're going to divide here. If you follow the stuff in that order, by getting rid of the fractions first, there's no chance that we start off with division. You can solve these without doing step 1. You can leave fractions in, you can leave decimals in. It makes it a lot of extra work with a lot of ways to fuck it up. We don't want to fuck it up, do we? Jared, do you want to fuck it up? Malaya, what about you? All right, any questions so far? Everyone get that down? Let's take a look at solving 2x plus 5. Equals 3. There are no fractions or decimals here. Good to go. We'll pass that one. We're going to deal with the addition by doing the opposite. This is like being 5 pounds overweight. I can't imagine just being 5 pounds overweight. I don't know that I've ever been 5 pounds overweight and have a memory of it. Even as a child, I was more than that. Idea is if you're overweight, you want to lose the weight. Lose in mathematics is subtract. I recommend doing like a little arrow with the equal sign to show to bring it down. And it also acts like the scale parter. If I have -5 over here, I want -5 over here. The equals comes down. 5 minus 5 goes away. These clear each other out. And all I'm left with on the left side is this part, the 2x. 3 minus 5, if you put it in a calculator, you get -2. That did step 2, getting rid of the addition and subtraction. Everyone with me so far? So now we have something multiplied by 2. The opposite of multiplication is division. We are going to divide by 2. Why did I draw my 2 with the crazy old curl in it? And I've never, that's a 2. Either way, 2 over 2, they cancel each other out. We did all that in that fraction shit. We do that over here. And on the left, I am left with an x. On the right, I have 1 over 1, which is 1, and I still have that negative sign. So the negative sign is part of it. And I have x equals -1. Now, one of the best things about mathematics ever, other than like it makes engineering and computers and everything else possible and video games possible, is that even as a student, when you're learning mathematics, once you have an equal sign in there, you can check your work. Let's show how to confirm or check your work. Confirm our solution or check our work. We do this by what we were practicing yesterday. Evaluate the equation with the solution. Or plug in the value of x. Okay, so I've got 2x plus 5. I did it again. I put a little curl in too. The fuck? What I'm going to do is I'm going to replace the x. I'm going to put in parentheses what I'm plugging in. I'm going to replace it with what I got, the -1. And I'm checking it. I like to put a question mark over the equal sign to show that I'm not making a statement that they're equal, that I'm just checking that they're equal. It's good practice. Two times -1 is -2, and then I've got plus 5. Does that equal 3? If I add those together, I get 3 equals 3. Bam. This verify our answer. This is pretty important. If you check your solution and it doesn't equal at the end, you made a mistake somewhere. And you really don't want to ignore it. Don't ignore it. Find the mistake. On the next problem, I'm deliberately going to make a mistake. It's going to happen. You're going to see it. I'll tell you, this was deliberate. It's the idea is to show you what happens when you check your work. This is a big thing. If you find that it doesn't work, don't ignore it. I've had students taking like Calculus 3, which is like borderline rocket science, check their work, get something like 4 = 5, and they'll like go and erase the 4 and put a 5. I'm like, no, it's not magic. You can't just wave a wand and get the number to change. It means you did something wrong. Now, your something wrong might be in your check, or it might be when you solve the problem. Usually, this is the easier thing to check first, and you'll see that in a second. When I make my mistake and I check it and get a wrong answer, I'm going to recheck this area first and confirm everything first. So in the next problem, we're going to have 3x - 2 = 7. And for the people that are just looking at the notes at home, I'm going to write, I am going to make a deliberate mistake. To show how it appears in the check. So when we're doing this, the first thing we need to do is deal with the -2, the -2. The opposite of -2 is adding 2. I'm going to put my equal sign down. My -2 and +2 cancel out. My 3x comes down. And here comes the deliberate mistake. 7 + 2 = 10. Right there, deliberate error. Then we have multiplied by 3. We're going to divide by 3. And I get x = 10/3. And now we will show that the check doesn't work. Put it in 10/3. Now I'm going to do that 3 times 10/3 over here. I can make it 3/1. And so we can put it together into one fraction. And the 3's cancel out, and I get 10 there. So this part becomes a 10. 10 minus 2, I'm checking my work, so I'm gonna put a question mark. Does 10 minus 2 equal 7? 8 equals 7. That's not right. Check showed it was wrong. So if I had this happen here, I would go through here and go, I did some fraction math here. Did I do this right? Did I do 3 times 10 over 3? Maybe rather than canceling it, I would say 3 times 10 over 3 is 3 times 10 over 3, which is 30 over 3. Do it a little bit differently. 30 divided by 3 is still 10. I did that part right. So the 10 here was right. 10 minus 2 was 8. So the error wasn't in the check. And we know where it is. But the point is, if you're going through it and looking for it yourself, you can check stuff. Come up here and start checking work and go, okay, it's added 2 to both sides. 7 plus 2 equals 10. Oops, that's where I made a mistake. I'm going to restart the problem from that point. I will put the correct thing here. Rather than restarting all of it, that should have said 3x equals 9. And I divide by 3, and I get x equals 3. I will check my work here. Three times 3 is 9. 9 minus 2 equals 7. Yes, it does. 7 equals 7. So now I know x equals 3 is verified. Don't force a square peg into a round hole. You learn that when you're 5 years old with those toys. You always get those like, here's these shapes, put them in the hole. And you, as most kids, will for a while put the wrong shape in the wrong hole and try to force it. It don't work. Any questions on that? The test is online, so I'm not going to see whether you check your work or not, but this can help you on anything that has like something that isn't done by the computer. You obviously can't check the computer's work. You got to trust the computer, but you can check some stuff. If anything you do by hand, you can mostly check it. And the final exam doesn't have any math on it. You're just doing statistics on it. So this is more of a skill set for you guys to appreciate and not really have to do if you don't want to do it. Any questions so far? All right. Onward, Miss Tessmacher. That's a Superman reference. I shouldn't do that. Oh, how many of you guys have seen The Real Superman with Christopher Reeve? This makes me so sad. Lex Luthor was played by Gene Hackman. He was the best Lex Luthor ever. Watch Superman 1 with Christopher Reeve. It's fantastic. I'm sure it's on Netflix or Paramount or one of those, maybe Amazon Prime. It's way better. Don't watch the one with Brandon Ruth in it. Don't ever trust bucket soap opera star to be a superhero. Brandon Ruth is from a soap. I don't know which one he's from, but I know he's from a soap opera. He actually, not fair. He makes a great The Atom in the Arrow TV show. I'm barking up the wrong tree. You guys are not my superhero group. Why am I wasting my time? Fuck it. Onward we go. Okay, don't do that. Let's kick it up a notch. Let's put some fractions in here. Okay. I have one rule when it comes to fractions and equations. Fuck fractions. Get rid of them. You don't have to write fuck fractions if you don't like cussing. If you do like it though, you should probably capitalize it. Maybe underline it, put a smiley face on it. Now, that doesn't mean there won't be a fraction in the answer, but we can at least go through it and not have to deal with them. The way we do this, we get rid of the fractions, is by finding the LCD, which we practiced doing the other day, and multiplying everything by it. So how did we do that before? We made a little table. And we factored the numbers and we put factors in their own columns. 5 is already prime. 10 is 5 times 2. And 20 is 5 times 4, which is times 2 times 2. The LCD is 1 from each column, which is 20. I don't know if I told you guys this. I know I told the previous class when I don't know if I told you when I was doing the table, showing you guys the table. I came up with this shit in the shower, like to help a student. I've never seen it anywhere before, and I went to check through this current textbook to like see how they're teaching specific things in case students go look there. And sure as shit, they're using my table. They stole it. I know they did. I know they did. And it's Woodbury. George, if you're watching this, I know you stole my shit. George Woodbury is one of the authors of our textbook, and he's a teacher here. I like George. He's really nice. He's helped me a lot as a new teacher when I was growing up as a teacher. All right, so I can either, I'll show it both ways. I can multiply everything by 20. And what happens? I have 20 here and 5 on bottom. I could multiply through and get like a fraction on top and bottom. I'm going to just do part of it right here. If I factor the 20, it's 4 times 5. And if I cancel out the 5s, I get 4 times 4. And there's still an X there. The reason why I didn't jump directly to the 16 is I want to point something out to you. This 4 is this 4 right here. What is the whole in my graph equal to? For the row, the denominator out of 5, 2 times 2 equals 4. That's that number right there. So you can really like bypass this and just like kill the denominator and multiply it by what's left over in the row. I can do the same thing with the, so I'll put the 4 times 4x is 16x. I'll write that down here. If I'm doing the 3 times 10, 20, I'm going to write as 2 times 10 real quick. Rather than, that way I take up a little bit less room. That's my 20 there. I can cross off the 10s, and I'm left with 3 times 2. And a minus sign. 3 times 2 is 6. That 3 came from there. This 2 came from here. And the 20s over here just cancel, and I'm left with 7. We can go through and now solve it normally. Notice there's no fractions left. That's what we like. We can add 6 to both sides. Bring our equal sign down. We've got 16x on the left. And 7 plus 6 is 13. Divide by 16, and I get x equals 13 over 16. So notice I have a fraction at the end. I can't get rid of it at the end, but I got rid of it along the way, and it makes doing the rest of the problem easier. In fact, the only other way to really deal with these fractions is to get a common denominator and then work with them as fractions. And when you do that, you're just going to have all of this stuff over 20, the lowest common denominator. It's a pain in the butt. I'm going to backpedal a little bit. I'm going to rewrite that equation we had above. And I'm going to put a little bit of space between each thing. The other option when you multiply by the LCD is to put the factors of the LCD rather than 20. I'm going to do 5 times 2 times 2 on each of these. Takes up a little bit more space, but hopefully you can see that this 5 cancels that 5, and I'm left with 2 times 2 times 4x. And 5 times 2 is 10. That cancels that 10, and I'm left with 2 times 3. And that goes to 20, and 20's cancel there, and I'm left with 7. Doing it this way might make it a little bit easier for you to, if you're uncomfortable canceling stuff on the top and the bottom, multiplying everything by the factored out LCD might make it easier for you if you're not comfortable with it. But eventually you're going to get to the 16x minus 6 equals 7. And if I were to check my work here, I would probably check it in the calculator. I'm going to write it here so I know what to put in the calculator. I have 4 over 5 times x, which was 13 over 16, minus 3 over 10. Does that equal 7 over 20? Okay, so I've got 4 fraction 5 times 13 fraction 16 minus 3 fraction 10. And if I do that, the left side says 7/20 now. The left side in the calculator gives 7/20. The right side is 7/20. Bam. My 13/16 was correct. There's actually an important lesson there that a lot of students don't really think about. Just because an answer looks ugly doesn't mean it's wrong. A lot of times when you're young and you're taking math stuff and like high school and stuff, like all the problems, not all of them, a lot of problems are catered to just give you whole numbers as an answer. You're used to seeing whole numbers as an answer. Getting fractions as an answer or decimals as an answer, you're like, that doesn't look right because you haven't really seen it. It's like growing up in a world without motorcycles, just cars, and all of a sudden someone goes by you on a motorcycle, you're like, what the fuck's that? Never seen one of those before. Or the people that have never seen the beach, like grew up like in Mississippi, not Mississippi, let's go Colorado. No, they got a river. Let's go Utah. A lot of places
still,
have
I
water.
feel like the river doesn't compare to the beach.
Yeah, fair enough. Let's say Colorado. You grew up in Colorado or Phoenix, Arizona. That's a dry place. And you go out to the coast and you're like, holy shit, look at all that water. It's like, it still takes my breath away, really. I'm like, God damn, not so much. When I stop and think about what I'm looking at when I go to the beach, like really like how much water that is, and really like, since it's going farther than I can see, like really like, holy shit, that's a lot of water. Like the first time you see the Grand Canyon. Now, every time you see the Grand Canyon, that never goes away. You're like, I've never seen a hole so goddamn big. Like, there's shadows down there, it's so far away, it looks hazy. It's like looking in the distance, it's so far away. It's enormous. If you've never been to the Grand Canyon, go sometime in your life. Okay, so let's make it uglier. And the only reason I'm making it uglier is because it's in your support sheet. I can't think of a time when you are going to have to do something like this. Not in stats. I don't know many scenarios in stats where this shows up, but they're going to test you on it. Malaya, right? Selena, Jared, Maddie, Cody, I know you guys. Okay, got it. What should we do here? Doing it and knowing what to do are two different things. What did we do last time we had something like this? Get rid of the fractions, right? So let's get rid of the fractions. So to get rid of the fractions, we need an LCD. Let's figure out what it is. Oops, I put a bunch of lines there, I didn't need them. 5 is already a prime number. 15 is 5 times 3. 20 is 5 times 4. I could break down the 4 to 2 times 2, but I don't have any 2s, and I don't have anything else to factor, so I'm just going to leave it as a 4. So the LCD is 5 times 3 times 4. And I tend to, when I do this in my head, I put numbers together that I know multiply really easily to make later stuff equal. 5 times 4 is 20, and that makes 20 times 3 easier for me. That's 60. So the LCD is 60. Either multiply by 60 or multiply by the factored out LCD. And all of this is over 1. And again, this should be what ends up missing here. 3 times 4 is 12. Notice when I cancel the 5s, that's what I'm left with, 3 times 4. So I'm going to have 12, and that's times the x plus 1. So it's got to go times all of that stuff, not just the x. Five times 3 is 15, and so I can cancel that 15 and that 15. And notice that's the whole we have right there is a 4. That's all that's left there. So I'm going to have 4 times the x minus 2. Again, I got to multiply it by everything on top, not just the x. So I'm going to put it in parentheses. And finally, 5 times 4 is 20. This is 20 times 3. I can cancel the 20, and I'm just left with the 3, which is that whole right there. So I have equals, don't forget the equal sign, 3 times x plus 7. All right, so now we got to go through and we got to do that distributing stuff. So 12 times x is 12x. 12 times 1 is 12, and I got a plus sign there, so I got to have it. And I'm going to take the plus 4 and I'm going to multiply it by the x, and I get plus 4x. And I do the 4 minus the 2, and I get 4 times negative 2 is negative 8. And I have an equal sign. And then I have 3 times x is 3x. And 3 times 7 is 21, and there's a plus sign there. This is why they teach the commutative rule. This next step is really unnecessary, but it does help new people doing it. I got x's all over the place. I need to get them all together. The first thing to do is get them all together on individual sides. The right side already has it. Over here, I want the x's together. I can switch the order of these two using that commutative property. And then I can add things together that go together. 12x plus 4x. Don't let the x fool you. Picture it like $12 plus $4. How much do you have? 12 plus 4 is 16. So I will have 16x there. And 12 minus 8 is plus 4. I'm gonna rewrite this a little bit closer to each other because I have a lot of space there that I don't like. All right, so that's where I'm at now. You have two options. We have x's on both sides. We don't want x's on both sides, so we gotta move the x's away from one of the sides. So I will show both options and why afterwards. I'll tell you which one I prefer. Option A is move the 3x. I'm going to subtract 3x from both sides. $16x minus 3x is like $16 minus $3, 13x. I still have that plus 4. And on the right side, I have 21. Now, this is like what we started with in the first examples. Subtract 4 from both sides. And we get 13x equals 17. And if I divide both sides by 13, I get x equals 17 over 13. Yes, Fanny?
I do the first part differently, but I still get the same answer.
How did you do it?
Instead of doing like 5 times 3 times 4, I just multiply the top part by 6.
That's fine. That's perfectly fine. In fact, that's how I did. What did I do, Les? Where are we? That's what I did here. I multiplied by 20. I'm showing ways that I also did it without using a calculator. Sometimes if you're doing a calculator, sometimes it like really goes quickly. You make it really quick. You can do 20 times, even if it's an ugly number. 111 times 16 over 3, you can do in a calculator really quickly, much quicker than you can do by hand. I'm just showing ways to do it by hand because it's good math practice. It gets you working well with numbers. The other option I have is instead of moving the 3x, I can move the 16x. I can subtract 16x from both sides. If I do that, I have 4 on the left. 3 minus 16 is negative 13x. And I still got plus 21. Then I would subtract the 21 from both sides. And the left side is negative 17, and the right side is negative 13x. And then I have to divide both sides by the number in front of x, which is the coefficient, which is the negative 13. You have to do the negative. Two negatives cancel each other out. And I end up with 17 over 13 equals x. I would recommend you try to move it so that your number in front is positive. Notice we got the same answer either way. The problem with this left side is I had negative 13x here, and that bad boy, that negative sign, disappears a lot, goes away a lot in people's work. And if you don't divide by the negative, the left side ends up being negative 17 over 13, which is exactly the exact opposite of what we wanted. We wanted positive, we got the negative. So if you do it where your number in front ends up positive every time, you can't possibly forget to divide by the negative. It's not a possible mistake. And at some point you go, I don't want to check my work on that one. You don't want to plug in 17 over 13 into that original mess? That's a no. You guys want do you guys need a 5-minute break or want a 5-minute break? Yeah, let's do that. I will pause this video so we can continue in a second. All right, so let's kick it up a notch. Well, I don't know if it's kicking it up a notch. I actually think this part's a little bit easier than that last thing, for sure. Dealing with decimals.
Sorry, can you share the screen, please?
Don't make me. I was about to say some shit I can't say to students. I'll take it after. No, fuck it. We're pausing right here. I don't want on recording. All right, so we're gonna work with decimals. Okay. The same principle that we have with fractions, we have with decimals. Working with decimals. I mean, I guess we could, since we're doing everything in the calculator, but there's still a lot of room for error there. Dealing with decimals is easy. Count the decimal places for each one and find the largest. I can't believe like 3 of you told me to check the monitor. Like 2 fucking seconds after everyone else. I'm like, yeah, give me time to respond. And then we're gonna multiply through by a 1 followed by that many zeros. Another way of saying this, it might be a little bit shorter, is by 10 to the d power, where d is that decimal places. I like that one because we're going to be doing scientific notation tomorrow, and we're going to be doing more with 10 to the d power. So it might be good to bring it up now. So this one's got 1 decimal place. This has got 2. That's got 1. And that's got 3. D here is 3 because that's the biggest number. So 10 to the third power, reminder of exponents is 10 times 10 times 10 is 1,000. And this is why I said a 1 followed by that many zeros. That's the spelled out version of it. But 10 to the D sound is probably a better way of describing it. The convenient thing, and we talked about multiplying by powers of 10 yesterday, is it just moves the decimal point to the right D steps. So I can look at these individually. I'm just going to do the numbers and show the shifting, and then we'll do the equation again. Moving this right 3 times, I gotta fill in zeros when I need to. So the 0.5x becomes 500x. And I move the 0.32 to the right 3 times, I gotta add in a 0, and that becomes a 320. So adding 0.32 becomes adding 320. Then I got an equal sign. Moving the 0.3 to the right 3 times, I have to put 2 more zeros in, and I have 300x. And on the 451, I move it 3 times, and here I don't need to add a 0. All right, so we got rid of decimals. The heavy error spot is gone. Now, we started with decimals. We're probably going to have something that gives us a fraction at the end. We want to put it as a decimal. If you start with decimals, end with decimals. If you start with fractions, end with fractions. So let's go through with this right now. We have x's on both sides. We want to put them together. So I'm going to move the one that has a smaller value. 300 is smaller. If I subtract 300x by both sides, by moving the smaller one, I make sure I end up with a positive value in front of x. Now, if you hate wasting paper like I do, once you've worked with this algebra a few times, when you've moved x's over, you can knock out 2 steps in one by moving all the constants to the other side. We're going to move that over there at the same time by subtracting the 320. So the 320 minus 320 goes away. The 300x minus 300x goes away. 500x minus 300x is 200x. And these are both negative numbers, so I can add up the numbers and keep the negative sign. That should be negative 771. Or if you do it in a calculator, you just got to make sure you enter it right. So I have 200x equals negative 771 if I put them closer together so it's easier to see. We divide by the 200. And I started with a decimal, I want to end with a decimal. Yes,
So if you start with fraction, you can leave it as a fraction.
you should leave it as fraction. You start with fraction, leave it as fraction. I'm going to do the caveat that unless the homework tells you otherwise. It might say enter a decimal. Sometimes they want to make sure you can do fractions of decimals and then do decimals of fractions. So they might tell you to do it as the opposite one. But in general, whatever you had with, end with. Or started with, end with. It's a good question. Now, checking your work here is calculator work. If I wanted to check this, I would plug in this on both sides. 0.5 times negative 3.855 plus 0.32. Does that equal 0.3 times negative 3.855 minus 0.451? And you just got to do both sides and figure out what that equals. You guys ready for more? Nope, I see Pin's gonna quit your rushing, Dave. We got time. So Jared, how's it feel with that sumbitch Subway guy? Like giving Jared's a bad name. Did you get any shit for that when you were growing up?
I mean, one time in high school, my PE teacher said, "Oh, Jared from Subway." I'm like,
That's fucked up.
He's too young to look at it. He was not a big guy.
"Oh, I know."
Yeah, I guess he did get in trouble a while ago. For those of you that don't know, Jared was the commercial guy for Subway for a long time. And then he got in trouble. Was it child pornography or just, I think it was child pornography.
There's a documentary of him on Max. He's on.
They made him this advertising spokesperson guy because he was a large, heavy guy like me. And presumably he ate nothing but Subway and lost a lot of weight. And they were saying, look, you can eat at Subway and lose weight. And then after a while, it became, look, you can be a spokesperson for Subway and be a pedophile. And nope, you won't be a spokesperson for Subway anymore. They will fire your ass. No one wants to be associated with a pedophile. All right, you guys ready for more? You guys ready to try one of these? Yeah, you guys are waiting to do one. You're like, I've been waiting, Jones. You've been doing all the work. I want to do one. Why don't you guys give this bad boy a try? Fuck. Let's do that. And you're gonna have to make Madison a custom version for the exam, that way she feels challenged.
No,
You don't wanna like feel challenged and feel like you're learning something?
no.
For sure, because I'm willing to go out of my way to make you an exam just for you, so that you feel like you've learned something. You sure? Well, you still got time, think about it, get back to me before, like Wednesday next week. I did that once. It wasn't last semester, it was last fall.
But how am I gonna learn the stuff that's on the exam then?
It's the same material, I just make the problems harder. I would have to do custom problems in my math lab, but it's a pain in the ass. I've made custom exam for Calc 3 students in fall. They had some hard stuff. One of the students is the son of a math teacher here. The other one is just super brilliant. He doesn't even want to do math or physics. He wants to be a computer scientist, but he's taking all the math and physics courses. And he's just super bright. And they were getting, like, one of them only missed one single point the entire semester in every assignment. And it was on the final exam. So like on the third test, I'm like, do you guys want to feel challenged? And they're like, yeah, we know we're going to get an A. It doesn't matter what you throw at us this time, we're going to get an A. So yeah, so I made a special exam for the one. I was like, you don't have to take this. If you take it, I will be lenient in the judgment because judging or grading because it'll be harder. And I had like 6 of the 30 students take it, and they did fine, just as well as they would have done on the other test. But I got recommended, don't do that ever, ever, ever again, because it looks like I'm peer pressuring students into doing it. And I wasn't. I said, don't take it. You can all take the regular test. All right, you guys do this, guys? Did you guys do this bad boy? Okay, so the most number of decimal places here is 3. I wrote 13 because I'm a champion like that. So we're gonna multiply by 10 to the 3, which is 1,000, which moves the decimal point 3 times. 0.21 becomes 210x. The 0.937 becomes 937. And the 1.45 becomes 1,450. We add 937 to both sides. And you get 2387 over here. And over here we have 210x. And when we divide both sides by 210, we get x equals, as a decimal, it was 11.366666, and it kept going. When you have something like this, you should just probably round to the number of decimal places you had. So we had 3 decimal places to start with. Let's end with that. So that's the 3rd decimal place. I'll look at that next number, and it's going to have me round up to x equals 11.367. Okay, so I want to point out something here. By rounding the solution, we will no longer get an exact check. But it should be super close. If I go back, and you should always do the check in the very first thing that you start with. If I check the 11.367 in the very first thing, and you throw this in a calculator, you will get on the left 1.45007. Does that equal 1.45? No, it doesn't, but it's off by a very reasonable amount. For rounding. An unreasonable amount would be something like 1.67 equals, not 6.67. 1.67, does that equal 1.45? That's too much error for rounding. Okay, you guys ready for some more? Nope, pins are moving. Slow your roll, Jones. All right, pins are no longer moving. Everyone ready? All right. Everything we've done so far today has been something called a conditional equation. What this means is the equation is true if x equals a specific number is met. This is so not helpful information for you guys, but it is going to show up in that initial quiz, and I want to make sure you know what it is. What does that mean? Solving gets an answer. Let me give you guys a problem to work out. Try that one. You guys get stuck? Did you get an answer?
It's one of those problems where you can't solve it.
That is what happens. Let's take a look what happens. For those that like got there and went, huh? If I distribute this, I've got 20x plus 4 times 20 is 80. And I bring my equal sign down. And 10 times 2x is 20x. And 10 times -7 is -70. If I subtract 20x from both sides, I get 80 equals -70. This is false. Which means, and it didn't depend on x. This is false, and it is false for any x. Because no matter what x I plug in, I'm going to have to subtract the same amount from both sides to cancel out the x's. It's going to go away. This means there is no solution. And no solution is called a contradiction. Guess what? That's not going to appear in statistics. The only way this happens in stats is if someone screwed up somewhere. There's no reason for this to ever happen. Let me give you another one. Six times 4x minus 8 equals 8 times 3x minus 6. So if you went through this, you get 24x minus 48 equals 24x minus 48. And an astute observer would know, already knows these are identical on both sides. But sometimes we don't notice it right away. So if you tried to get the x's all on one side, you're going to get -48 equals -48. And this is true. And it didn't matter what X was. So X equals any real number. If you want to see a mathy way of writing that is like this. They like to do an R with a double vertical line for the real number set. That's just some fancy jazz. That crazy looking E means X is in. What happened to one of my pages? It disappeared. What? Good catch. Why didn't I look down? Gravity, hello, works. Okay, so there's really only, there's three outcomes, three possible outcomes. X equals a single number, it's called conditional. X has no solution, or the equation has no solution. This is called contradiction. And finally, X is any real number. And I didn't state what this was above, but this is called identity. Only reason I'm showing this is in the sport quiz stuff. You shouldn't have to worry about this topic right here at all. You probably won't have to deal with those super complicated equations other than in support quiz stuff. You will be working with decimals a lot. I think that the real message here is it's getting you practice working with math that might be harder than what you need for stats. So you'll be ready to kick ass on the stats part. And you're not gonna have to worry about a lot of that complicated shit on the actual tests. How's that sound? All right, we got two more pages we gotta do. It's really one topic. But I hate to ruin everybody's day, but stats should be called word problems class. And going through the homework, most of these questions are word problems. And a lot of students don't like word problems because it requires translating words to math. So we're going to give you a little practice on it today, and we will hit on this more tomorrow. Let's look for some keywords. Keywords are, the first one that's really important is looking for words that have the equal sign or represent equal. You can see is, tells you equals. You see was, yields, gives, are, results in, or we might actually see the words equal or equivalent. For the plus sign, addition, you might see the word add or plus, words we commonly associate with that symbol. But we also might see more or greater. Or you might see some or total. Sum or total are both outcomes of addition. A lot of times when we say total, we kind of mean all of it, but total really is implying just addition. All the other operations like subtraction and multiplication and division have their own word for the outcome, which we're going to talk about. For the minus, we could see subtract or the word minus. Those are common words. Less or fewer. Or we might see difference. Difference is the outcome of subtraction. Oh, multiply, I already got a plus sign. Well, we might actually see the word multiply. And another one we associate with it is times. You might see factor, but that's not really a common one. The one where it represents outcome is product. Product is the outcome of multiplication. Finally, divided. Of course, we might see the word divided. You might see split or split up. Or shared among, maybe. The outcome of addition is called the quotient. Oh, I know some crazy shit I can give Matt. I can give her some complicated fucking sentences. Like they're convoluted. You're like, what the hell does he mean? God damn it, Jones. Why are you fucking with me? You guys ready for a little bit more? We're almost done. We're getting out of it early. I'm going to give you a couple sentences. We'll walk through them together, and then I'll give you a sentence. Translate on your own, see how you do. We're going to start off with 5 times the sum of a number and 2 is 13. I always try to find the equal sign first in a sentence if there's gonna be one. And that's the word is. This is really splits up the sentence and the equation into two halves. What comes before the sentence and what comes after the sentence. What comes after the sentence is after the is 13. That's the other side. So now I look at the left side and it says 5 times. 5 times means I'm going to take 5 and multiply it by 2 numbers. I'm sorry, then it says 5 times the sum. 5 multiplied by 2 numbers. So I got to add them together. 5 times whatever follows. What follows is the sum of a number and 2. 5 times. The sum tells me addition. And so what am I adding? I'm adding a number and 2. I don't know what the number is, so I'm just going to give it a letter. Let's go with Y. But I know what the 2 is, so we're going to use that. So without the little dot there, because this is another way of doing it, that's what that sentence translates to. Did you watch the Vampire Diaries or anything like that?
Yeah.
Okay. The originals?
I started it, I never finished it.
The originals was great. What was the head vampire? Klaus? He's great. We watched the Vampire Diaries in the originals, so that's a show we watched. I realized like there's got to be something. It used to be one of my slides. As time goes on, I put slides in, I take them out. If I only put them in, it'd be probably like fucking 80 slides right now. That takes too long. All right, let's do the next one. Where the next sentence is the sum of 5 times a number and 2 is 13. These two sentences have the exact same words in them in different orders. And the result is going to be different. I still have the is and the equals and the 13, so that's one side. The sum of tells me I'm going to be adding 2 different values. What are those 2 different values? The and is what separates them. 5 times a number is one value and 2 is the other. I don't know what the number is, but I know it's multiplied by 5. I can use y again if I want. And then the sum tells me I'm adding it to whatever follows, which is the 2. So the order of words matters. Thankfully, a lot of stats problems aren't those types of words. A lot of stats problems are like, researchers did this survey and they found this many people like Coca-Cola over Pepsi. And then we're going to be doing stuff with that. So, but this gets you thinking about how the math words show up and what they mean. Let me give you guys one to give it a try, see how you do. the difference of y and 3 is the quotient of y and 5. Everybody got an idea what they get? What'd you guys get? Maddie, you know everything. What do you got, Maddie? Did you not do it?
I didn't get this one.
What did you get? How do you know you didn't get it?
But does quotient mean equal?
No, quotient is division.
Okay.
It's the outcome of division. What'd you get, Malaya? Malaya, right?
I get
Y minus 3 divided by what? Y what? Y plus 5. Okay. Cody, you got anything? What'd you get? You didn't do it, did you?
I wrote y minus 3 equals y divided by 5.
Okay. Selena, what'd you get?
Y minus 3 over 5, divided by 5y.
Like that?
Yeah.
All right. Jared, what'd you get?
I wrote the same thing Cody wrote.
So we got C-Dog and Jared on that. Malaya was on that. And Selena was on that. What'd you end up with? I'm making everybody answer this question. Fuck it, we got a minute.
I just did y over 3 over y plus 5.
Y minus 3 over y plus 5. So the first one. So both m's are on the first one. M and n. One of these is correct. Let's see which one. Okay, so if I'm reading through it, difference of y and 3 tells me that I am going to be subtracting y or 3 from y. So you guys all got that part. Excellent work. We got y minus 3 everywhere. I got an is. Is an equal sign. So we should have an equal sign in here. The quotient of y and 5, quotient is telling me I gotta divide one of these by the other. It's the first one by the second one. So Cody and Jared both got it right. The rest of you, with valiant effort, good learning opportunity, right? There's some work in here. We'll be doing some more stuff with this on tomorrow, and then we'll do chapter 5's like math review stuff, which is easier, I think, in this section. Other than that, fuck out. I feel awkward saying it with you guys. You guys don't like cuss much.